Alright, so hey guys, and welcome to my presentation on simple harmonic motion. Okay, so we're first going to consider where the equations for simple harmonic motion comes from. We start by looking at the motion of a particle around a circle, as you see here, and we see that the horizontal displacement can be expressed as a cos theta, where a is the maximum displacement, the radius of the circle, so to speak. Then, using high-quality 3D graphics from the movies, we can rotate that circle and look at it from the side. And when we do, we see that the horizontal displacement from that equilibrium position can still be expressed as a cos theta. We also see something else interesting. This can actually be viewed as a model of simple harmonic motion, like a mass on a spring. So using the same logic, albeit in a vertical position this time, we can see that the displacement from the equilibrium is still a cos theta. We know from circular motion mathematics that theta is equal to omega t. So x is then equal to a cos omega t. Okay, so here's where things are about to get spicy. If we differentiate position with respect to time, dx by dt, we get v, or velocity. So using simple trigonometric calculus that if you can't do, you really shouldn't be on this physics course. We see that v is equal to minus a omega sine omega t. Then differentiating velocity to get acceleration, we can see that dv by dt, or a, is equal to minus a omega squared cos omega t. Now the astute among you might have noticed this is very similar in form to the equation for displacement, x equals a cos omega t. So combining these we get an alternate equation for acceleration, a equals minus omega squared x. So if we substitute in F over m for a, we see that force is now proportional to the displacement, but in the opposite direction. This is a key factor of simple harmonic motion. Now we know that for a system like a mass on a spring, F equals minus kx. And if we combine this with our previous equation, we get the equation omega equals root k over m. We also know that omega is 2 pi over t, so combining these two equations we can see that t is 2 pi root m over k. This is another important equation to know. In fact, here's all the equations you should know, so you can take notes and have them for yourself to